Hello, Professor. I want to start to present my work on structuring games to perform better in a cloud environment with respect to reducing latency. To start off, I want to begin to give the base foundation of cloud gaming. Well, cloud gaming is fairly seen as a modern day invention or creation where games are involved in the cloud. The process is usually done through thin clients to end user systems. Well, thin clients is basically just a simple computer that has been specialized or optimized for establishing a remote connection with a server-based IT environment. To move on, one of the major problems with cloud gaming is latency, and our goal is to keep latency at a minimum or at a low when gaming takes place on the cloud. This is where a Cdn comes in. Cdn is being used to implement changes and give a positive effect on gaming on the cloud. The next step is the research questions which I came about during my research for Cdn. Well, the questions are: how does Cdn reduce latency? Does cloud gaming with Cdn have a lower latency compared to cloud gaming without Cdn? And finally, is implementing Cdn in cloud gaming an effective way to reduce latency? To move on and to go on from the presentation, I would love to touch on the problems Cdn was designed to solve. And my demonstration video will handle these research questions. Well, to go on, I'm giving an instance where a gaming developer in the US has developed a game and has pushed to production by hosting it on a server at the USA. After the marketing, they noticed the gamers in Netherlands are interested in the game, and the gamers in Netherlands have to query the server. The size of the game is up to 50 gig, so the gamers in Netherlands would have to query the original server, which is in the USA. So let's say, the server in the US have to serve the file to the endpoint, and the endpoint is the gamer, person playing the game. Naturally, this will always be slow and it will take time to get the downloaded content because of factors like bandwidth, which is from the service provider of the person in Netherlands, which is the person playing the game in Netherlands. So basically, Cdn was designed to solve these latency issues, and it was used to design and solve this problem. So with Cdn, the files are cached to the nearest edge that is closest to the gamer. This means that the gamer wouldn't have to query the original server in the US for the game files, but just mirror edge closest to the gamer. Basically, the mirror edge that is closest to the gamer is the node which will be captured and which will be cached for easier and faster processes. Now, I would like to show an example of the methodology which I used in implementing the effect of Cdn in cloud gaming. Now, I have an account with AWS where I created a cloud storage called buckets. In this storage, it currently shows two buckets. The first one is what Amazon used to track all the activities I do on my account. But what we're really concerned about is the bucket called Giovanni Gaming. This is the bucket used in my script, in the script. In this storage, I have two files, the games.zip and the PC games.zip. Please note that the results and the files downloads in this presentation are only for the demonstration purposes only. In my report, I already used the PC games.zip file as my file download because it is a larger file of 736 MB. For this presentation, I'm using a very light file, which is the 227 KB, 227.7 KB for the demonstration purposes. I'm also not using it with Cdn because the file is very small, but I would like to show the process of activating the Cdn feature of this bucket as proof of consent. I also, in this presentation, in my work, I also used a clock watch and a timer to improve my accuracy when taking the time. Also, in addition, I have a Python file which is connected to the S3 bucket, which are written to handle this for me. The Python file queries this bucket and downloads the file and also takes the time at which the file is downloaded. The Python file which I have written to handle this, which I had mentioned before, is here. The Python file which queries the bucket and downloads the file and also takes the time at which the file is downloaded is this file. And this is the file which is used for the demonstration purposes. So I open the new file, open it in my terminal folder, and then I would like to also run through the code implementation now, just to show you how the Python script works together. So the bottle 3 is used for connecting, while the time is used for taking the time. The login is used for tracking the activities, while the JSON is used for processing the files. I imported some of these dependencies, as you can see at the beginning, for connecting and logging the files. The request and get is used for the access queries, and the cost here was used to import my access key ID and my secret key ID from AWS. Well, this is to show my access key and the secret key. This is why I installed it. So I just open up nanocons.py, which shows my access key ID as well as my secret key ID. So I first start with a prompt to check whether I would take in a test with Cdn or without Cdn. Then I connect with the bucket name Giovanni Gaming, which is here, and it's showed on my Amazon S3 bucket, Giovanni Gaming. And I download this file. So I run this file and take the time measurements. So I will run this script now to show. So here it asks me type Y if you're testing with Cdn and N if you're not testing with Cdn. So I'm going to press N. So while that is activating, I will show the process of how to activate the Cdn feature for this bucket by clicking on properties. Then I go to a feature called the transfer acceleration, which is here. The transfer acceleration is the Cdn feature for the S3 bucket on AWS. This means that I can use an accelerated endpoint for faster data transfer. If I click on Learn More, you will see in the description, that transfer acceleration takes advantage of globally distributed edge locations in Amazon CloudFront. As the data arrives at an edge location, the data is routed to Amazon S3 over an optimized network path. So basically, I'm using the CloudFront Cdn feature from Amazon whenever I activate the transfer acceleration feature of the bucket. But it is currently disabled because I am showing a demo and a presentation example of the methodology approach which I used in implementing the CDN on the bucket. Then we move back to the results from the games file. As you can see here, it did take about a second, just 1 second, and this further shows the timing is accurate because it shows the clock, the duration clock time, as well as the duration time, and they are both the same. And also, it shows my IP, which is the local IP, and these are being stored in a file. Well, I would like to show the measurements taken and where the measurements was stored in. So the measurements taken was stored in this file, nano.cdn.txt. What this means is because the file is small, we couldn't notice a big difference in latency. But in my report, I have already demonstrated that you would notice I used a larger file containing open source games, which really shows the intensity and the upside effect of using CDN in cloud gaming. So back to my presentation, I was able to notice the gaps. So most papers explained CDN and its benefits, but were unable to identify the implementation in cloud gaming. As well as these papers were not able to gauge and look at how cloud games are run with and without CDN. This is where my motivation stems from. Most of the papers and surveys looked at are considered too outdated or too old for a complex technology topic like CDN. However, in this my paper and in my research, I've been able to carry out measurement efforts to compare and evaluate the performance of cloud games with and without CDN. So with the use of CDN, it can be gone in the direction of reducing latency, and this could help the IT sector and a lot of cloud gaming developers who are always trying to improve quality and gaming experience. So cloud gaming providers who are still finding a challenge to find a new approach or new strategy to reduce latency could use the content delivery network as a new approach. This will give and encourage a lot of cloud game providers to develop new business models around the content delivery network. To go on, these are the results that were taken with the pcgames.file right here, which has more MB, and this is what I use for the project or for my project. To go on, all this is located in the Amazon S3 buckets, which I had mentioned previously. As you can see with CDN, the time reduced drastically than without CDN. And all these tests were carried out in different locations by a community of web developers in other countries. You can see the difference in Nigeria with and without CDN and all the other countries. Thank you.